This topic might be new for some of you guys, and also part of our user base is already on board with the Azure Trusted Signings. But we'll have to do a quick recap about and tell you what this is and how to set the room for everyone. Before I jump into the details, let's overview the agenda quickly. We'll talk about what is trusted signing and smart app control, how these two work together, and we're also going to talk and what we've seen from our users in the last 12 months since we've integrated trusted signing in advanced installer, and we've been also using it personally for our own daily builds. And this spring, we've also done new integration with Microsoft that will allow you to build SBOM reports for your packages, another step forward towards increasing your security and providing a higher level of trust with your customers, especially enterprise customers. What is trusted signing? Traditionally, we've been used to storing certificates directly on our machines or on a flash drive. So in the last years, there were some expensive and complicated enterprise solutions for storing certificates in the cloud on certified hardware, because that's the main purpose. But they were just like pure native storage machines, and there wasn't a service that would help us manage the certificate through its life cycle. So we still had to manually renew that certificate from wherever we decide to buy it and update it and make sure that it's managed properly on that cloud without giving access to unauthorized persons. In that view, most of us had to stick to the classic method of buying a certificate, storing it on our devices, and just trying to apply the best practices not to get that certificate being stolen by some attackers or used for bad purposes. And this has worked with its pains, as we all know, but something changed about 2 years ago when our beloved corporations, of course, that run the software industry decided that all future certificates must be stored on certified hardware to increase the security level. And it's a certified hardware that's PIPS 140-2 level 3. This name for the certification sounds like a spy agency movie or something like that. But anyway, I had to note it down because I can't remember it, sorry. And of course, most of us, regular Joe, and in our small companies don't have this kind of certified hardware, because it's not practical to buy expensive certified hardware just for development and build machines. So we're left with two options. We either buy a cloud service that manages our certificates and stores it on this certified hardware, or we use a flash drive, which is much easier to get a small piece of certified hardware. But this makes it harder because it adds a layer of manual work in signing operations, as you'll see later on. If you remember anything from today's talk, is don't use a flash drive to buy a certificate that you want to use in your daily build pipelines or weekly build pipelines, whatever build pipeline. So it's okay to use a flash drive with a certificate for authentication, for signing documents and stuff that you don't do automatically, but not for build servers or build machines. With Trusted Signing, which is a solution from Microsoft, you get access to an end-to-end signing service that allows you to sign not only code, but also documents and applications and much more. And you can see the full details in the webinar that we hosted together with our Microsoft product manager last year. Just go to this link, advancedinstaller.com/trusted signing from our website, and you'll find the link to that announcement webinar where they share more details. But being a service means that you don't have to worry about renewing the certificate, managing its access, because it's part of your Azure subscription. You have full role-based access control and log analytics. So you can monitor constantly who has used that certificate, what has been signed. You can even revoke a signature done in a certain time frame. And this is much easier because Azure Trusted Signing service provides a new certificate every 1 or 2 days. I don't remember exactly the interval. So when you revoke a certificate, you don't revoke all the signatures that you've done in the last 12 months. You just nullify those from that interval. So in the case of somebody is a bad actor is getting access to your certificate, reduce the impact of that security breach. And of course, you also have native integration with Advanced Installer and other Microsoft tools, as you'll see later on in my demo at the end of this. I'm not a big fan of paying money for just basically, which is a number, a really big hash, but using trusted signing has really made our lives a lot more easier than buying and renew certificates from different vendors. Making sure that we have access only on certain machines. It was a nightmare when we were testing something related to digital signing and so on. With access to that management control from Azure, we can easily pass control from one user to another. We can issue test signing certificates as the one that I'll be using today. And it's been really a breeze going that. And talking about trusted signing, is important because it relates to smart app control, and this is a new feature, a new component from Windows 11 that blocks potentially harm applications or application that could harm or slow down your device. So you can think about the smart app control as a combination between smart screen and defender, and we don't always like them, but their main purpose is to help us and prevent breaking the machines with infested applications. The way it works is that when you run an app on Windows, SAC will check to see if the system cloud power security service can provide a prediction on whether the application is safe or not. It is a cloud service that considers the app safe, and then the local engine from the operating system will let it run. If the security service will not provide a prediction, SAC will just check if this package is digitally signed with a valid certificate, of course. And if it's not, Smart App Control will block it. And Microsoft enables this by default on every new Windows 11 installation. So if you have a PC that has migrated from Windows 10 to Windows 11 or some other situation like that, you will find that this service is disabled on those machines. We also noticed that it gets disabled automatically if you ignore multiple cases of flagged applications. So like if you say Smart App Control to, okay, let this app run, even if it's not signed or even if it's untrusted or stuff like that, at one point it will switch back to being disabled because it doesn't have enough information to make proper predictions. As with any antivirus solutions, any security solutions, we can expect to see some false flagging. And we've gotten those false positive detections quite a lot with Defender over the years. But you have the possibility to bring this up to Microsoft and investigate and eliminate from their service. So usually it's not really a big headache if you test your app before release and just allow the cloud service from Microsoft to properly distribute the updates for the security updates to all the Windows machines. And as I said, is designed to run on a clean machine. But if SAC is disabled, all the work goes back to Windows Defender and its classic actions of scanning the applications that have been installed. So how does this influence your installers? And when you have SAC enabled on a Windows machine, it seems to currently block DLLs or exe or PowerShells files that were used as custom actions inside an MSI. And according to Microsoft, SAC Smart App Control should be able to flag an application based on the presence of digital signature or on its usage if there is an application that it's not signed but used by a lot of people. Because there are like open source tools and stuff. So Microsoft is trying not to block those ones, but at the same time, there is a risk of attackers cloning a repository of a well-known source application, making small changes and trying to distribute that as the valid main open source application. So it's a fine level of of security checks on this part. And the safest way at the moment to eliminate the risk of falsely flagged installations is to sign every DLL or exe that gets included into your installer and not just the installer itself. So we've still seen users and even big vendors that don't have a proper practice of signing every file from their package. They just build the final exe or MSI installer and sign that at the end in a separate process from the installation. And from our perspective, this is not right because you should have the signing integrated with your build process. So build the binaries in Visual Studio or whatever IDE you have. Then you compile, you set up the project for the installer and let the tool, the installer tool that you're using, be it Advanced Installer or any other tool, communicate with Sign tool and make sure that it asks Sign tool to sign any package that gets included in the package. Your DLLs, your EXEs, our DLLs and EXEs and scripts, whatever Advanced Installer includes, you will see that that gets signed too. And it's signed with it basically signed directly from our end, and only if you change something it's going to be re-signed with your certificate, because we don't want to have packages created by customers blocked because we just introduced a predefined custom action that manages your IIS website or whatever other predefined functionality from Advanced Installer you are using. And to do this, we sign with our own certificate all the binary DLLs that we include in your setup package. And this way we ensure that the binary files that we included are Smart App Control compatible. This makes it much easier for you to build your installer without having to worry about digitally signing each custom action from the package or other resources that we include. And in addition to that, we also recommend you include your only digitally signed files in your setup package. So if you have your own custom actions or other binaries that get part of the package, we strongly recommend you sign those and keep that signature valid in case you build a new version and stuff. Just make sure the signing process is part of your build pipelines accordingly. Going back to trusted signing, as I said, the service would not be useful if it wouldn't be tightly integrated with your daily development tools, starting from Visual Studio, GitHub, and Azure DevOps, all the tools from Microsoft, and also featuring our native integration in Advanced Installer that we released last year. And we've been using that for over a year now. We had no problems. Every month we release a new version. Every day we have daily builds. The only thing that we've seen is a slight increase of like 10 seconds in our build time. And this happens because the signature is done by sending a hash of the files towards the Microsoft Cloud. So there are some messages exchanged, but the files that get included in the package, those never leave our machines. So their security is never guaranteed. So as with any feature we add, the goal was to increase your productivity by simplifying the reducing the volume of work you need to do. In the past, actually, even now, the current version of Advanced Installer has included the trusting signing libraries and tools from Microsoft directly, and to make it easier for you. And in the last months, Microsoft has released a trusted signing redistributable separate package, which they recommend to be installed separately from your IDE tools, be it Advanced Installer or Visual Studio or whatever tools you're using. And to go with that direction, we've started removing the previous way of managing those libraries. And by the end of this quarter, so probably somewhere in the beginning of the summer, the next versions of Advanced Installer will automatically detect if you have those redistributable for the trusting signing libraries is installed. If not, we will automatically install it for you as a separate MSI, which it wasn't the case until now. And your build pipeline should work the same as they used to work before. If you're a new user, the same behavior will apply for that, and it shouldn't affect it. We'll document this entirely on our website to understand how it works, even for build, for CI/CD pipelines integration, all of that. And as you'll see in my demo later on, it's working without any issues. But before I show you how this integration looks in Advanced Installer or in our official extension, I want to emphasize a very important feature from Trusted Signing. And Microsoft didn't only made it easier, and this, I don't think it applies only to Microsoft. I haven't used a cloud certificate from other vendors, but I know that there are a few others that have released something similar. You'll have to research the price and their functionality if you don't want to use the Azure Trusted Signing support. But with any cloud service, it should be easier to manage that certificate and to renew, because you don't store anything locally. So in that case, Microsoft takes care for us for not only renewing the certificate, but also securing the authentication protocols, especially when the integration is so deep with the sign tool. So you don't need to keep a password locally and to specify a password when you sign the package anymore, or store that password in a file on a machine. The way you authenticate with the new Trusted Signing service is that you authenticate with your Azure account, and that account authentication is stored in your Visual Studio credentials, in your Azure CLI login, in your browser login, using the OS of security, integrated security. And sign tool will just request a signing operation. It will receive an authentication session from the operating system. So you don't store anything related, anything security sensible in your project that or in your command line scripts that will make it easier for an attacker to steal that certificate and gain access to it. We have a dedicated article on our blog with more details about how the authentication will work and what options you have to authenticate, and I'll share that in the final resources slide from this webinar. But before we go into our demos, I also want to talk about a new feature which we've done together with Microsoft tools. So this is the support to generate SBOM reports or software bill of materials. This is relatively new in the software development world. We've been talking about it a little bit more in the IT and software asset management circles, but not so much with developers. So practically an SBOM is an inventory of software components, that includes critical information about the library, tools, processes, and whatever else you deploy with your application to your customers. It's useful for IT departments to easily audit and keep a track on outdated libraries shared by an application, or whatever other dependencies those applications have usually. A similar report is actually already included in a structure of all MSIX packages, but it's not an SBOM report by its name. It's called a block pack file, and it's an XML file, if I remember correctly, and it's not using following the same standards as SBOM, because the SBOM standards are public standards agreed upon by the entire industry, while the block file is is common, is specially dedicated to the Microsoft platform and only for MSIX packages. But the role that it serves is similar. It allows the OS and software inventory tools to identify the components and to make sure that whatever was installed on the machine is mentioned in that report. So you don't have additional files that were not part of the package there, or files that were modified, which is something that you can also check with a digital signature, but this is a cross check on that. So the standards, the public standards for SBOM, you'll see that the most common used are, there are actually two standards, SPDX, and that's called Software Package Data Exchange, and Cyclone DX. I don't know that name, from where does it come, but it's one of these two formats that you'll have to use. And as I showed in the demo, you'll receive a file that gets generated. The way we do that in Advanced Installer is we integrate the SBOM tool generator from Microsoft. This is an open source tool that they have published on GitHub, and you can integrate that in your own development tool if you're building such thing, or just use it from the command line if you don't want to use our integration, or for other projects where you can't use it together with Advanced Installer. And now let's have a look at some demos of Trusted Signing and SBOM generation. So I have here a small test package that simulates the installer for our MSIX troubleshooter. And this is actually an old application that we had in the past. Now this is part of PacKit as a feature of PacKit. It was a small single window application where you can just launch an MSIX package and see information about its installation when something was failing, and helping you to troubleshoot that if you have an expired certificate or some other reasons that we learn along the way. So to enable and to use Trusted Signing in your package, it's very easy with Advanced Installer. You just have to go to Digital Signature in your project, and in the left menu, after you've enabled signing. As I said, we're currently using built-in tools, but in the summer, with the future updates, we'll start detecting the existing sign tool from your Trusted Signing distributable. We'll detect that automatically, so you don't have to. But if you want, you can also change to a custom tool and manually specify the path to your sign tool and whatever command line you want to be modified if you want to. We've had cases where this was necessary depending on the usage. And once you enable Trusted Signing, all you have to do is specify some information that can be easily made public, because this doesn't affect this is not related to any authentication protocol. So we just have to specify the endpoint. If I remember correctly, Microsoft said they have 6 regions where they serve the Trusted Signing service. I think one of ours is still in North America, and even if we are based in Europe. So if we change that to Europe, it could be even faster. We could even get faster builds in the future. But as I said, it's like a few seconds slower to build time, and that doesn't affect us in any way, because it's when you sign a build every couple of hours or so, it really doesn't matter. Then you need to specify the account name, which is again nothing that can be reused by an attacker, and the certificate name. Here I have created a test certificate, so that's really easy with Trusted Signing. You don't have to purchase anything additional. So the pricing for signing is based on usage, on how many files you have, and it's very generous. So we sign Advanced Hour every day, and we have thousands of files, so it never passed over our goal time. It's costing us $10 a month or something like that. And once you specified all these details, you can just let Advanced Installer do its job. So when you trigger a build from the command line or from the UI, as I did, we prepare the files that get to be included in the package. We also sign the resources before we include them inside the cap files from the MSI in this case, or inside the MSIX package. And then we also sign the package itself entirely. So if you look in the status windows, there was a message saying signing exe file, and there was the name of an exe file from the package. Now, after all the files were inserted, We also signed the MSI with our test certificate in this case. And this package also has SBOM activated. I'll show you that in a minute. So let's see the output folder of this package. So if we go and check properties, we should see the test signature as you see here. But this makes it very easy for us to give access to our quality assurance team to a test certificate and to some of our developers without increasing the vulnerability of our main certificate that we use to sign the official releases, and allows us to easily test different signing functionality or different applications for whatever purposes we have internally. As I said, this has been a real game changer for us. And here we have the SBOM report, but I'll show you that in a minute. First, let me show you how you can generate the SBOM report, which is even easier than enabling signing for your package. So in product details for your package, there's a new tab now called SBOM. And here, all you have to do is to enable this option, generate SBOM. And Advanced Installer will automatically configure the SBOM tool from Microsoft to use as input the resources that you have present in your files and folders, and other resources that we might include in the package and might be relevant to the SBOM report. And you can also specify a path to your output folder from your IDE. So wherever you build your binaries, DLLs, everything that you have, and you have your source code next to it, of course, you can specify that too. And the SBOM tool from Microsoft was designed to scan and detect dependencies referenced by your application, either from Visual Studio solutions or from various other development frameworks, and map those inside the SBOM report alongside with the files that you have included into your application. The only thing that we've seen to be not easily identifiable, and that's kind of reasonable for the moment, is that if you get the source code from a well-known open source library or something, and you then modify it and recompile it with your own name and information on metadata information on that package, it will not be able to identify that as a modified library, but that's kind of acceptable. And let me show you a report. So the reports that I said were basically some JSON files, and if you open that file, you'll see entries like this one. These follow the standard SPDX or CycloneDX format that is a common standard applied across the industry, not just by Microsoft, but by many other big companies and vendors, and all the software asset management tools follow those standards and can easily interrogate the reports that you deliver. The first version of this integration in Advanced Installer is designed, as you've seen, to build the report next to the output of your build, next to your MSI. We are currently working on a new version that will automatically include this report as part of your package, just as you've had with the block map file from an MSIX package. So this allows you to deploy an installation to your users that contains a report, an SBOM report, with all the information about your package, your dependencies, their versions, and your users can safely trust that report and say, hey, Advanced Installer is using this version of X library and it's up to date. And we actually found a library that was outdated while we were working on this integration. And that was updated too. I think it was the XPath library, if I remember correctly. But it will also allow your users to easily monitor application, and also allows you internally to keep track of those applications. But we might even add support in Advanced Installer to to help keep an eye on the dependencies that you have, depending on the user's requests that we receive from you. So I think this is most of what I have to talk. So you have more resources on our website and our Microsoft website, search Trusted Signing. We just published a new article on our blog. I forgot to include that link here about how SBOM works and how you can use it. Just go to our blog and it's part of the last articles from the last month. First question from Bob. Is there an AWS alternative to Azure Trusted Sign? I'm not aware of any alternative from AWS at the moment. Maybe there is, and I just didn't research it. I know there is one from DigiCert Cloud or DGC. I don't remember exactly the name. And I think there were others that were working on solutions. Maybe AWS has been working too, but I'm not aware. Probably all major cloud vendors will try to provide some sort of solution for managing your certificates in their cloud on their certified hardware, because it's a good value add on their infrastructure. Yeah, another good question from Simon. So in Advanced Installer, in the digital signature page, we have multiple options. So you can use Trusted Signing, as I said, certificate store locally. Usually use that for test certificates, because now, or self-trusted certificate, if you have those internally into your network, because you can't buy any new certificates that you trust that are deployed locally or from a file. And then you have the options to use Azure Key Vault or Device Guard. So Device Guard service is going to actually be deprecated, and Microsoft has already started making announcements about it, and it will be replaced by Trusted Signing going forward. It's just a process that takes some time. But Azure Key Vault is a separate service. So the difference between Trusted Signing and Azure Key Vault is that Azure Key Vault just provides you the certified hardware where you store the files, but you have to purchase the certificate from a vendor. It can be Microsoft or somebody else. You have to renew that certificate manually, and you don't have any advanced role-based access management or integrations of the same level that you have with Trusted Signing. While as Trusted Signing is probably, Microsoft never said that, but it's probably using a similar infrastructure or the same infrastructure from Azure Key Vault, where they use certified hardware to store the certificate profile themselves. But on top of that, they added the layer of management where they actually generate and assign you the certificate once they validate your identity in their Azure platform. They renew the certificate for you, so you don't have to trust it. Don't have to remember every 2 years to renew it. They give you the option to revoke it, and you have logs, and you also have this wonderful test profiles that you can create, and also the role-based access management. So it's a much more complete. Think of it as a powerful wrapper over Azure Key Vault. As I said, I don't know if they're using Azure Key Vault as the backbone for storing the certificates themselves, but it's Azure Key Vault delivered in a much more simpler way and much cheaper. From what I remember, and I've heard from customers, Key Vault, the Azure Key Vault service could get really expensive at the time. And a question from Lofty. So your article says that purchasing an EV code signing certificate will prevent marking, and this was true, but after a few months, this is no longer true. I want to be sure that Azure Trusted Signing prevents marking too. Do you have any resources from Microsoft? So this is the default recommendation from Microsoft. I don't remember seeing anything that was 100% offering a 100% warranty from Microsoft saying that if you sign this package is trusted by Smart on Screen, because as Microsoft told us directly, and other antivirus vendors also said, even an attacker could buy a certificate through a legal means and then choose to use that certificate to sign a malicious file. So the way Microsoft analyzes the packages and makes sure that those are trusted is a black box partially, and it will always be like that, because otherwise, if it would be completely documented, every attacker would try to work around that. It's strange that the situation that you had where smart screen initially approved your application and a few months later it said it's no longer true. The only moment when we saw that was when we changed the certificate. So in the past, we had the classic certificates stored on our machine. So when we renewed the certificate, we had a few months of headaches when basically trusted signing was just resetting our reputation from scratch. But ever since we, and I'm talking only personally about our experience with Advanced Installer, which is installed by tens of thousands of users, ever since we've started using trusted signing, from day one since we signed it, and up until now, we never had a problem with smart screen. So its reputation experience was much better than when we're using classic certificates. That being said, it only costs you $10 to test it. And if you already have an Azure account, the validation process is pretty smooth because they have a history of your invoices with of your company with them and so on. So it's not really hard to test it, and it's just and not expensive either. With an EV certificate, you would have to spend hundreds of dollars on certificate, and then you still have no warranty. But here, it's just going to cost you $10 to test the 1 month of signing with the service. So next question is from George Barold. Thank you, George. We are also using Komodo EV, even though when I ask about the solution, Advanced Installer did not mention any other solution, so we acquired it at a big price without knowing or getting information about Azure. Although now you are pushing it and have it at least for a year. I'm sorry to be disappointing you, George. Maybe you can get a refund from them if you still have time. Basically, we try to not recommend the vendor itself, as I said. So we built integrations with most of Microsoft tools because these are very user solutions and based on the requests that we've seen from our customers. Hopefully, the Komodo AV certificate will bring enough value on you and you can start saving more with the next upcoming renewal. I'm really sorry to hear that you didn't find out about this earlier. Okay. So another question from Lofty. We are using Komodo stored on a YubiKey flash drive. When we download our software, my screen shows a warning from 1 year ago for Microsoft changes. And if we use this trusted signing, will the smart screen, the warning disappear? As I said before, it should disappear, the smart screen. We never had problems with it, but we didn't have to build a reputation for trusted signing in any way. Just the moment we released a new build, signed with a new certificate, it was never blocked from day one. And you can try this. So even if you have the Komodo certificate, you can buy an additional certificate from Microsoft. You can have multiple certificates at the same time. And for $10, you can test this and see if it's flagging your application in any way. It's strange that they do this with an extended validation code signing certificate. But as I said, part of those validations are black boxed on purpose. Okay, an anonymous question that says that from April 1st, Microsoft only allows signups from companies from US and Canada for Azure Trusted Signing. This is something new. I didn't know. So we're based in Europe. We never had a problem with signing up, and that was over a year ago. And somebody posted a link saying that they might have added Europe. I have to follow up on these links too and see why they did added this limitation. So for the folks interested, there's a link to the Microsoft community talking more about this limitation. This is something new. Hopefully the new trade deals and other security stuff won't affect us even in this scenario. Sad to hear that they limited this accordingly, but maybe it's just temporary. Thank you for sharing this information. They didn't bother informing us or others either. They just made a generic post like, hey, doesn't matter if you're from anyone else, we don't care. Typical Microsoft. Starting last year, March 2024, Microsoft changed the way Marin interacts with EV code signing certificates. It still says these are the high trust certificates available, but they no longer guarantee that they instantly remove the smart screen warning. So what I know specifically from Microsoft is that the certificates from the trusted signing service are not extended validation code signing certificates. So these are classical called signing certificates, not EVs. And somehow, up until this point, we never had a problem with that one. So the best thing is just to try it with $10. And now, of course, if you're based in North America, because it seems that Microsoft doesn't want us to try it anymore, or other European companies. And if you can try it, then just switch on whenever you feel like you have the time to switch and stop using the old certificates. A question from Hog. Where is the SBOM catalog consumed? Is just for documentation at the moment, or what security solution of Windows honors the SBOM? So according to Microsoft, the SBOM can be consumed by the operating system or by the SBOM tool itself. If you want to run the tool from the command line and say, hey, validate this SBOM report. So if you have an infrastructure where you want to validate that packages delivered have been untouched. And it is also consumable by tools, by software audit solutions from your enterprise. So those tools usually have an agent deployed on every machine from the company that can scan the machines and consume and report this information back in a central dashboard useful to the security department. Microsoft said that they basically have started adopting SBOM as a default in any tool they are building at the moment. It is included with PowerShell, or it was included, I don't know, because there was at some point when we were testing, there was a few builds that were including the SBOM generation. I don't know if it was on a development branch or something, but at some point they temporarily disabled the SBOM generation. But they said that they basically have generating it for thousands of builds up until that point when I last talked with the SBOM team. And it is on a clear roadmap of being the default to report from any setup package that Microsoft delivers. One question from Simone. Azure Trusted Signing is currently limited. Yes, Simone, it's currently limited to United States and Canada, as one of our other users said. So there is a link on the techcommunity.microsoft.com/blog/Microsoft Security blog, posted April the 2nd, 2025, where Microsoft gives us more details. Jay Chang says that we've been using Trusted Signing for a while, but I noticed the Google Chrome flag the installer has not trusted sometime when the Microsoft Edge does that. Is there an issue with Google Chrome with Trusted Signing? I can't say that for sure. So if it's doing the same for us, our users haven't reported this. We never noticed this issue with Chrome, but make sure that you also sign the files inside the package if you don't do that already. Other than that, you can try to ask on the Microsoft Tech Community forums for other recommendations, because I doubt, well, it's harder for Microsoft to respond to, but I doubt that you'll get an answer from the Google team on their logic for flagging these installers. There's one more question from Simon Stein, a very good question. I don't understand why you don't have to authenticate an advanced installer when using Trusted Signing. How does Microsoft know that you have a valid account and which one to use to sign? Yes, so as Hawke says, there is a login session that's usually cached by the operating system. So before this demo, because this is a fresh machine that I've started using a month ago or something, I installed Azure CLI, Azure command line, and I've logged into that command line. So basically, you'll get a prompt like this when you install the command line. It will say, just click this link, enter this code to authenticate. Or if you don't do this, the first time when you build a project in Advanced Installer, the build progress will pause and it will open up a prompt in your browser. That will be a prompt to log in with your Microsoft account. And basically, the authentication will be done via the browser in that case. There are multiple options. You can define an environment variable. You can be logged into your Visual Studio account. So any one of these methods, it's enough for the sign tool, because sign tool is built by Microsoft too. Is allowing sign tool to read the authentication token from that session cached on the machine, and execute the signing operation as long as your user has the correct signing permissions, because you could be the owner of the certificate, but you could not have it could be configured that you can only manage the certificate but do not have access to sign with it. So you have to read the documentation from Microsoft on that part. Obviously, for security reasons, I can't share a screen with the dashboard from our Azure account, but basically you have to add the role for trusted signing profile publisher, if I remember the name correctly, once you've created the certificate profile in your account. And for us, for example, for me today, I just had to log in yesterday into our Azure account, added my role as a trusted signer, so I can use it for these demos and for this test certificate. I'm not using the real publisher certificate. And tomorrow, when I'll clean up these samples that I've shown you, I'll just go back into our Azure dashboard and revoke that role for my account. So this way I make sure that if somehow my account gets access to, or somebody is trying to use it to sign it, it will not have permission. So it just makes it very easy. Yeah, so as Hockey says, make sure to use the right account if you have, especially if you have multiple Azure subscriptions, like maybe you have a personal subscription, or then you have a company one, or I've seen problems with cache logs in, you, as Hockey says, you need to make some voodoo magic to make the window login reappear, because it was caching the old login, and it's going to say that this user doesn't have the right credentials to authenticate. So try to use the Azure CLI command line to get information about which subscription account you're logged in. And there are also some command lines from Microsoft that allows you to manage and to see the status of your certificate access. If sometimes the errors in Sign Tool are not very descriptive, I'll give you that. We try to add more information around the errors that Sign Tool is giving back to us, but it's never been easy. Okay, one last question from Simon. When you use builds in Azure DevOps, yes. Thank you, Simon. So I forgot one part of the demos. So when you use builds in Azure DevOps or GitHub Actions, yes, my screen is still shared. So here I have a GitHub action defined in a test repository. And in the YAML file, you have to specify these secrets. Of course, you will define the secrets in your settings, your repository settings. We have an article on our website that says how to sign package with Azure Trusted Signing from GitHub Actions, similar with the Azure DevOps, I assume, but even easier with the Azure DevOps, because it is you're basically probably using the same account to authenticate from Microsoft, so you don't need the secret back there. But GitHub is a separate service. So with GitHub, you need to specify the secrets for the Azure tenant. And then in your YAML file, all you have to do is to make sure that you have .NET as a prerequisite, because it's required by the Sign Tool version that is used by Trusted Signing. And then you just build your advanced installer package as you regularly do, because advanced installer itself will execute Sign Tool, and Sign Tool will find the environment secrets that you've configured and will use them for signing the package. Thank you, Simon. I forgot about this part of the demo. And this is how it works with GitHub, or as I said, for Azure DevOps, it's even easier because it should have the same Azure account, so you don't have to configure anything additional. Thank you all for joining us today. It's been a great session. If you have more questions, follow up on support@advancedinstaller.com and let us know if we can help anything or what other features you might want us to add in the future in Advanced Installer. Have a great day. Bye.